Hey students, this is Miss Wendt, and I want to give you kind of a little intro to get started with your Gizmo called Ionic bonds. Okay, so this paper you should be putting in Notability if you don't have a paper copy. If you have the paper packets I made, it's in there. And it starts off with a couple questions to do before using the Gizmo. So number 1 here says, Nate and Clara are drawing pictures with markers. There are 8 markers in a set. Nate has 9 and Clara has 7. What can they do so each has a full set? Okay, well, it looks like Nate has 1 extra marker and Clara is missing 1. So we could have Nate give Clara 1 marker and then they would both have 8. So you would write something like that on this blank right here. Okay, question 2, similar. We've got Maggie with Fred and Florence. Maggie has 10 markers, but Fred and Florence each only have 7. How can they share markers so each has 8? Okay, well, Maggie has 2 extra markers. So it looks like she could give 1 of her extras to Fred and another 1 of her extras to Florence, and then everybody would be happy that way. Okay, now what we're talking about, the markers here, is exactly what atoms do with electrons. If you have extra electrons that you don't need in your outside shell, you can give them away. If you need some more electrons, you can get some from a friend. Okay, and the rule is that you want to have a full shell of electrons. Okay, so I'm kind of type that up here. Atoms are stable if they have either 0 or 8 electrons in their outside energy level. And lots of times those energy levels are called shells. Okay, so if an atom has close to 0, maybe it only has 1 or 2, if we give those away, then the atom has 0 electrons and it's happy and stable. If an electron has close to 8, like 6 or 7, it can pick up a couple extras in order to get that full energy level of 8. Okay, now our simulation today is going to help us see those things. Okay, so we are going to go to explorelearning.com and kind of mess around with some atoms. So let me open up Explore Learning. Now remember, when you go to Explore Learning, you want to use the login button in the corner up here. And your login is probably the same as whatever you use to log in to Schoology. If you don't know your login, please let me know. And again, I have a teacher page, so it's going to look a little bit different. And here's ionic bonds. I'm going to move this up to the top for us here. So when you log in with all these cool gizmos, ionic bonds should be at the top now for you. Okay, so I'm going to launch this, and you should do the same. And what I have here is pictures of 2 electrons. You can see that there's a nucleus and there's electrons in these energy levels, and it's only showing the electrons in the outside. Okay, these other inside energy levels would be full of electrons too. Okay, so it starts me off with 1 metal and 1 non-metal. And I can click these buttons here to kind of show the formulas of things and the charges and all that stuff if I want to. And let's read the hint here. Drag electrons from metal to non-metal atoms. Use the add metal or add non-metal button to add more atoms. When you're finished, press check. Okay, so this red one here, my little key says is sodium. He's got 1 as his outside shell. My blue one here, that's chlorine, has 1, 2, 3, 4, 5, 6, 7 in the outside. Now, I could look these up on the periodic table. Sodium is in group 1, chlorine's in group 7. Those groups tell us the same as the number of electrons. I'm going to grab this electron here. Oh, look what happened when I did that. Did you see the center here? When I take that electron away, that atom now has a positive charge. Okay? Before I do anything, the number of positive protons in the center and the negative electrons in the outside was the same. They canceled out. But if I take an electron away, now there's more positive protons and less negative electrons. Now that's got a positive charge. I'm going to put this on the chlorine. And look at that. When I add that electron, the chlorine now has a negative charge because it has more negative electrons. Okay, now over off the side, here's my formula. What I have right here, I have one sodium atom and one chlorine atom. So it's showing one of each. Okay. I got my charges shown there. And these guys would be attracted to each other. A positive and a negative would be attracted. Okay, so if I'm not sure, oh, see, I'm going to hit check here. I think everything is good. My sodium atom's happy. It has 0 electrons in the outside. My chlorine atom is happy. It has 8 electrons. This -1 and this +1, they kind of cancel each other out. I'm going to hit check. And it says, good job. I have created sodium chloride. So that's the name of these guys that would be together. Because after this happens, the positive and negative would stick together and they would be bonded together. So that's pretty cool. Okay. So it would look something like that. And I could zip up the speed if you want to, but it might make you kind of dizzy. So I can hit reset, make it all go away. Ooh, that's pretty. I'm going to change this. Maybe I'll do aluminum and phosphorus. And you can see that aluminum and phosphorus have a different number of electrons. If I change it to oxygen, that's different. If I change it to chlorine, that's different. So you're going to see the different ways that these metals and nonmetals can go together. The metals are always going to have a couple extra electrons to get rid of. The nonmetals always need a couple. Okay, so that's basically what you're doing with this. You're seeing how the electrons can move from one to the other and make sure that both of those atoms are happy and stable. Okay, let's go back to your worksheet here. Okay, so there's that same picture we just looked at with sodium and chlorine, and we figured out how they go together. We could count how many valence electrons they had, how many electrons in the outside, so we can fill that out. We tried pulling electrons away. So the one where the electrons can put away is a metal. The nonmetal will hold their electrons tightly and you won't be able to pull those away. So, oops, I just closed that window, but that's okay. Okay, so try to pull electrons away from both of them, see what happens. For some reason we get these big blanks on your paper. I'm not sure why that is. Okay. So then you are going to write down how many electrons they have, how many protons they have, and just, kind of see what the screen says and just count things and write them down. What are the charges? So those are the positive and negative numbers. And then you'll kind of do another one and another one and another one. Okay, so you'll try all these different combinations of atoms and write down the formula. And the formula will tell you how many of each kind of atom you have. So in some cases, you need more than one kind of atom to make everything happy and stable. Okay, so this is a little intro to how this works. I'm going to make another video with some more details on ionic bonding, and hopefully you've seen the other links in your folder, so you kind of see electrons moving and all that kind of good stuff. This activity is a 2-day activity to give you a chance to kind of view videos and mess around with it a little bit. So I hope you enjoy it. I hope you don't skip it. And just get used to the idea that electrons in atoms move a lot. They hop a lot from one kind of atom to another kind of atom. And that connection is called an ionic bond. Okay? So try the activity. Be on the lookout for more videos in the future. And if you have any questions, as always, go ahead and Zoom me or let me know. Thanks, guys. Have a great day.